In spite of all recent progress in green technologies, we are still heavily dependent on fossil fuel. Transportation sector accounts for a large share of CO2 emission, while private full electric and hybrid cars have already become a common sight on the streets, and their rate of adoption is constantly growing. The decarbonization of other areas such as marine transportation and long-distance aviation is more problematic. The adoption of Power-to-X technologies may bring a solution for these problems. The basic idea of P2X technology is to convert electricity to another form of energy, which in case needed can be converted back into electricity. P2X technology has a wide array of possible applications, including production of synthetic fuels, various chemicals, and even edible proteins. The replacement of fossil fuel with synthetic fuel produced in ecologically friendly way with a greater use of renewable resources would reduce the overall systemic emission without the need for significant modernization of existing infrastructure and transportation equipment. P2X technology has been extensively researched at Lund University since 2014. During 2019 to 2022, Lund University conducted a feasibility study for synthetic fuel plant. The plant could utilize excess hydrogen from local chemical company and CO2 from local manufacturing companies. The final production is gasoline, kerosene, and diesel, which can be sold to energy companies and eventually to end users, who can be both private and business customers. By replacing the fossil fuel with synthetic one, the project will not only reduce the overall system carbon footprint, but it will also increase the circularity of the whole regional business ecosystem by utilizing the raw materials which otherwise would be released in the atmosphere as emissions. The utilization of excess hydrogen as raw material results into reduction of the final product costs, as the project does not require dedicated and expensive hydrogen production facilities to be built. The advantage for the end user is that the synthetic fuel does not require immediate and costly infrastructure and equipment renewal. The project can be viewed as a step towards creation of hydrogen economy, which also aligns well with the recently published Finnish National Hydrogen Roadmap. The project facilitates smooth transition towards emission-free energy and transition systems and enables utilization of hydrogen without problems associated with handling the pure hydrogen by private consumers. The project creates new business opportunities for the region, contributes to energy security and circular economy development.